Hello. In this session, we will study about the differentiation. Let us see what is differentiation. Differentiation is the rate of change in y with respect to x. The x-axis, y-axis, and this one is x-axis. This is the x-axis, this is the y-axis, and this is the origin. And we have a function like this. This is a function we have. We have a point. There is a point. This one is x. So we see that the coordinate of this point would be, this point is P, we assume it is a P point. The coordinate of this point would be x and f of x. This would be the coordinate of point P. There is another point here, and distance from here to here is h. To here it is h. The coordinate, the abscissa of this point would be x plus h. Now the coordinate of this point Q would be x plus h, it is the abscissa, and f of x plus h is ordinate. Let us see, if we draw the tangent at point P, the tangent would be like this. And another tangent, if we draw here, it would be like this. So if I coincide Q on P, then h tends to 0. The h that Q comes to P and tends to P, the h tends to 0, and the tangent would be coincide. For this, first of all, I would like to tell you one another thing regarding this. If I draw a perpendicular here, and this line, this is the 90 degree, and meet this also, and the angle is this one, this angle is theta. So this is a M point. So QM is equal to f of x plus h minus f of x, because the from here to here we get f of x plus h, and from here to here we get f of x. So the QM is equal to f of x plus h minus f of x, and the PM we already know, it is h. So what will happen, tan theta perpendicular upon base, therefore in triangle PMQ, where angle M is equal to 90 degree. So tan theta is equal to f of x plus h minus f of x, this is the perpendicular, and h is base. But here we want q to be coincide on p, so h tends to 0, we have to take the limit h tends to 0. If we take the limit h tends to 0, then it would be differentiation of y with respect to x. dy upon dx is equal to limit h tends to 0 f of x plus h minus f of x upon h. So this is the differentiation. In this way we would get the differentiation of any function. So let us see some example. We have a function y is equal to x power n. We have to find out the dy dx of this. So how we will get the dy dx of this? I will explain you. See here, y is equal to f of x. So f of x is equal to x power n. Therefore f of x plus h is equal to x plus h power n. Now we have the formula for dy dx. dy dx is equal to limit h tends to 0 f of x plus h minus f of x upon h. Now we will put the value here. Limit h tends to 0 f of x plus h is x plus h power whole power n. X plus h whole power n minus x power n upon h. Here we see limit h tends to 0. We expand this by the binomial theorem x plus h, so we will get n combination 0 x power n plus n combination 1 x power n minus 1 into h plus n combination 2 x power n minus 2 h power 2, and so on. We will get at the last in this expansion we get n combination n h power n, and there is already minus x power n. So what will happen? Divided by h. Now limit h tends to 0, n combination 0 is 1, so it is x power n plus n combination 1 is n x power n minus 1 into h. Other terms we keep same as it is, n minus 2 h square plus 1, n combination n is again 1, so it is h power n minus x power n. Divided by h. Now x power n is positive here and x power n is negative here, it will eliminate, and is equal to limit h tends to 0, and we take h common outside in numerator, so there is h and x power n minus 1 only here, because the h we have taken it outside. Now n combination 2 x power n minus 2 into h power 2, and h we have already taken outside. In this way we will take it outside from this bracket, and here h power n minus 1. Let us see in denominator. There is h. Now this h and this h will eliminate to division, and limit h tends to 0, we have nx power n minus 1 plus n combination 2 x power n minus 2 h and so on plus h power n minus 1. We have only this. Now we put the value 0 instead of h, we get n x power n minus 1. This is the ddx of x power n. So in this way we could easily find out the derivative of any function with first principle